Yeah. So, good morning, students. Once again, in the previous class, we discussed about cyber sickness. So, what is cyber sickness? This cyber sickness is one that is an example for indirect effect of VR simulations. Is it clear? And even we discussed system characteristics and user characteristics. So we are going to see the block diagram here. So this will help you to understand what is cyber sickness model. So first part of cyber sickness model, we have discussed about system characteristics and the user characteristics, how it will influence the cyber sickness or how it will influence the user. These two things we have seen in the previous class. Now, one more factor is there, which is very important, especially in cyber sickness, and that too, it is in between the user, that is human body, and the virtual environment. This particular degree of interactivity is actually, we can say that it's a factor. Is it clear? And it is expressed as users navigation techniques. So users navigation, how user, what type of technique is using, it's okay. But that navigation technique used by the user is also one important factor. Is it clear? So, and a technique what they technique vaadam valla maybe the user may get some sort of effects like what drowsiness kaavachu or some sort of headache kaavachu. So like that. So it's nothing but a technique vaadam valla endante we are going to say that user is getting interacted in the virtual world through that technique. We are going to say navigation technique. So this particular degree of interactivity is nothing but a factor where it can be expressed as what users navigation techniques. Definitely this users navigation techniques also influence cyber sickness, and that is what we are going to represent it, this particular factor as one degree of interactivity. Okay, now based on this particular meaning, or we can say that what is the definition of degree of interactivity like that. So we can particularly when the users are interacting with the simulator through an interface, we can say. So when we are interacting with the simulator through an interface, and if simulator in the sense, for example, let us say that I'm going to interact using the HMD device. Is clear? HMD head-mounted display. Using that, I'm trying to, for example, roller coaster. Another game. So when we are experiencing that roller coaster, so there it will ask us to hold one what we can say a support for us. Okay, support patkomane okati adugutundi. Nothing but we are going to say that it's an interaction. So when the user interact with the simulator through an interface, so definitely whole jayapannappudu we use that, it will some sort of muscles interaction will be there, and limbs movement. Is it clear? All these things will happen. So when we say that user is interacting with the simulator through an interface, so they will exercise their muscles and move their sensor limbs, and thus the sensorial data to the central nervous system is sent. Is it clear? So such data will always play an important role in reducing the effects of sickness through accelerated adaptation. Is it clear? So in general, when we are interacting any particular virtual environment, is it clear? Through a simulator, so we need to apply some force to leather. We need to what we can say, our muscles may get some sort of extraction and contraction. Is it clear? So like that, that is some data anta kuda store ayundi actually ga. So that particular data actually plays an important role so in reducing the effects of cyber sickness. So one example was given by a particular scientist. So that scientist's name is Stanley and Hash in the year 1998. Clear? They designed one particular game or a task, we can say. So that game is known as here virtual maze. Is it clear? Virtual maze. The task involved is navigation through a virtual maze. This is what? The virtual maze. I'll just take it here. Okay. This is what I'm going to say. The virtual maze. I hope it's visible to all of you. This virtual maze. Yeah, this particular virtual maze is nothing but one type of game. I think you might have seen that. Can you identify the path of that particular? In some newspapers or in weekend magazines, when puzzles is shown, in that puzzle you might have seen that. Show me the path of the tiger in that puzzle so that it will get the food. Maybe ఒక end side ఏమో ఒక goat పెట్టడం and another end ఏమో starting terminal దగ్గర ఏమో ఒక lion గాని tiger పెట్టినప్పుడు it has to find the path in order to reach that particular animal so that it will have its that particular animal as a food. I think you might have remembered this type of games. Is it clear? So the task that is taken by this Stanley and Hash, is it clear, is nothing but navigation through a virtual maze. Is it clear? That navigation can be done through windows or through doors or using elevators. Actually, three concepts itself. This is one door, this is windows and elevator. Is it clear? So for this task, 29 subjects were taken. Out of these 29 subjects, 14 are male and 15 are female students. Is it clear? And these 29 subjects, they are wearing active glasses. So I think in input, in HMD, output devices, we have seen active glass intended to center. So these people, they have used 20 active glasses and they navigated through the maze, which was displayed in stereo on a CRT. The study used between subjects design. See here, control conditions. Because subjects were 29 subjects were considered. Is it clear? And these two subjects were divided into two groups again, male and female. So 14 were male and 15 are female students. These are all college students and they are using active glasses. They are wearing active glasses, navigated through the maze. And this is displayed in a stereoscopic display, that is CRT. So here different controls were used in order to complete the task. The task, what is the task that is taken here? Navigation through a virtual maze. So what are the different controls here? The controls are passive control, active control, combined active passive control. So like this, three different control methods have been employed. Is it clear? So these three control methods were used by these two groups. So in each experimental group, 8 subjects were considered and the task performed is for 30 minutes. Is it clear? Task specific motions are nothing but what? Through doors, windows and elevators. Clear? So the users navigated through what? Joysticks. Is it clear? And 8 subjects in each experimental group were considered and each group performed the task for 30 minutes. So like this, all the groups were tested with different control techniques. And the entire virtual environment was displayed on a PC in a stereoscopic display so that subjects wore stereo glasses. The results showed that active-passive control reduced significantly the cyber sickness effect. So out of these three different methods, active-passive, that is combination of both active and passive control, reduces the cyber sickness in a significant manner. And the worst condition is the passive control. This is what. So active passive control is better than active control because unnecessary motions are eliminated. This is one important, thus reducing the amount of neural conflicts. So both reduce adaptation time. So simulation sickness was self-reported by subjects using a simulation sickness questionnaire. A questionnaire has been prepared and it is given to all the subjects and that with the different groups. And finally, it is concluded that active passive control is better compared to the other one. Is it clear? Active control, passive control are the two different cases. You can see here, active passive control is giving us the better method. You can see here, the SSQ score is very less in this particular case. And of course, all the four characteristics were observed. Nausea, oculomotor distortion, disorientation, total severity. అంటే ప్రతి గ్రూప్ లో అంటే నౌసియా క్యారెక్టరిస్టిక్స్ అబ్జర్వ్ చేశారు. సో వెన్ ఎస్పెషల్లీ ఫర్ దిస్ నౌసియా క్యారెక్టర్ యాక్టివ్ పాసివ్ కంట్రోల్ మెథడ్ వాస్ ప్రూవెన్ బెటర్. Even in the oculomotor distortion also active passive control was proved. So like this, for all these four cases, it is proved that active passive control is the better one. So SSQ ante ekku unte anta severity unnattu. Please do remember, SSQ is nothing but simulation sickness questionnaire. The score ekku undante obviously severity of that is also more. And cyber sickness is more in that case. The symptoms, either symptoms severity undachchu. Symptoms emem undachchu andi like nausea, oculomotor distortion, disorientation, total severity. All these are different what we can say the symptoms of what cyber sickness when this particular method was used. So degree of interactivity anedi, so definitely it is also proved that. So this degree of interactivity is also an important part of what cyber sickness. I hope you understand degree of interactivity that is very important in this case. So next one is that neural conflict. What is neural conflict? So neural conflict is nothing but the phenomenon in which when simulation and body sensorial feedbacks conflict. అంటే simulation నుంచి వచ్చిన feedback ఒకటి and body sensorial అంటే user for example ఒక suit వేసుకున్నప్పుడు there are different sensors that are employed కదా. A different sensors ఉన్న suit ని when we are employing, so definitely that sensors will give us some sort of feedback, no doubt about that. But even you can observe that. So when we are doing some action, అంటే for example ఒక hand movement sensor ఉందనుకో, a hand movement sensor hand movement చేసేటప్పుడు even in the virtual world also hand movement should be there. Is it clear? So that simulation we need to consider and body sensorial ఈ రెండింటి నుంచి కూడా feedback తీసుకోవాలి. When the feedback that is taken from the simulation as well as body sensor, if they are different, the conflict వచ్చే chances ఉంటాయి. Is clear? So this particular conflict we call it as neural conflict. Is clear? So this particular neural conflict occurs when simulation and body sensorial feedback both are differs. And this particular neural conflict can be of three types. One is type 1, type 2 and type 3. So type 1 is nothing but two simultaneous conflict signals A and B. Example, information from a moving platform doesn't coincide with the motion of waves seen on HMD. So when we are using a head-mounted display, there you need to closely observe the motion of waves on the scene on the screen and information from a moving platform, because మనం ఫిజికల్ గా మూవ్ అవుతున్నట్టు ఉండాలి. అప్పుడే కదా సెన్సార్స్ విల్ సెన్స్ that and that will be given, the data will be given to the virtual human being also. So let us take two signals here. Data signals అంటే simultaneous, అంటే ఒక సిగ్నల్ information from a moving platform, you can take it as A, and information from the motion of waves seen on HMD is taken as B. ఈ రెండు సైమల్టేనియస్ గా జరిగేటప్పుడు వచ్చిన కాన్ఫ్లిక్ట్ సిగ్నల్స్ నే మనం టైప్ 1 సిగ్నల్ అంటాం. టైప్ 2 సిగ్నల్ ఏంటంటే సిగ్నల్ A is present but B is not, అంటే B absence ఉండొచ్చు, A is present. అంటే when we are moving, sometimes it is not possible to get the same movement even on the screen. అంటే వర్చువల్ వరల్డ్ లో మనం మూవ్ అవుతున్నట్టు కూడా అక్కడ వర్చువల్ హ్యూమన్ బీయింగ్ మూవ్ అవ్వలేదు, మనమేమో మూవ్ అవుతున్నాం కానీ అక్కడ మూవ్ అవ్వట్లేదు. So this particular type of neural conflict is categorized as type 2. Similarly, type 3 is there. Signal B is present and signal A is not. Type 1 ఏమో both A and B signals. ఇక్కడ signal A అంటే ఏంటి? Nothing but information from a moving platform. User move అయ్యే platform base చేసుకుని దాని నుంచి వచ్చిన signal. దాన్ని we call it as information A. Another one is there. మనం మూవ్ అవుతున్నప్పుడు వర్చువల్ వరల్డ్ లో కూడా మనకు ఆ పర్టికులర్ వర్చువల్ హ్యూమన్ మూవ్ అవుతున్నట్టు చూపించాలి. It has to show. Okay, is it clear? So when that particular signal B is also moving, is it clear? ఈ రెండు కాన్ఫ్లిక్ట్ డిఫరెంట్ ఉన్నప్పుడు కాన్ఫ్లిక్ట్ అవుతుంది. Is it clear? So we take this particular conflict as what? Type 1 conflict. Type 2 conflict ఏంటి? Signal A is present and signal B is not present. Similarly, type 3 signal B is present and signal A is not present. That is what. So example for type 2 is what? Looking at roller coaster simulation without a motion platform. So when we are experiencing this particular roller coaster in virtual reality, we are not moving, just we are experiencing virtual world as if we are moving. Though when we are experiencing it in our HMD, so మనం యూజ్ చేసేటప్పుడు you can say that. So I'm going to say that when we experience virtual reality of this roller coasters in VR. So roller coaster already designed model, virtual model. In that virtual environment, it appears that we are moving. Actually, we are not moving physically. So that means what? Physical move అయినప్పుడు signal ఒక signal, virtual move అయినప్పుడు ఒక signal గా కన్సిడర్ చేస్తాం. So example for type 2 ఏంటంటే signal A is there and signal B is not there. Actual గా మోషన్ ప్లాట్ఫామ్ లేదు, సిమ్యులేషన్ లో మాత్రం మూవ్ అవుతున్నట్టు. That is what. Looking at a roller coaster simulation without a motion platform is an example for type 2 neural conflict. Type 3 అంటే example flight simulation in fog. Motion platform moves but visual feedback is unchanged. అంటే ఫ్లైట్ సిమ్యులేషన్ ఎగ్జాంపుల్ తీసుకుంటే ఫాగ్ లో, అంటే కంప్లీట్ గా ఒక ఫాగ్ లో ఫ్లైట్ మూవ్ అవుతున్నట్టు ఉండాలి. క్లియర్? మోషన్ ప్లాట్ఫామ్ ఈజ్ ఇన్వాల్వ్. Motion platform is involved, అంటే flight is actually moving, but visual feedback in that particular visual scene on the screen, we are not going to get that virtual movement. Virtual flight movement is not observed. This is what type 3 signal. Since more information from the simulation results in more conflict, it is logical that neural conflict induce cyber sickness and that grows with the duration of immersion in the virtual environment. So in neural conflict exists అయినప్పుడు when more time is considered or when more time is taken or when the duration of the immersion is more, then in that case definitely we will get an induction of cyber sickness in us or in the users. This is what neural conflict. Is it clear? I hope you understand. So neural conflict is nothing but what? The conflict that appears or that is created because of what? Simulation feedback and also body sensorial feedback. So this particular neural conflict is categorized as again three types: type 1, type 2 and type 3. In case of type 1 neural conflict, so the signal A and B both are simultaneously conflicting signals when we consider. Whereas type 2, only one signal is present, that is signal A is present and signal B is not present. Similarly, type 3, signal B is present and signal A is not present. Examples are considered for type 2 as what? Roller coaster simulation. For type 3, flight simulation. These are the two examples for type 2 and type 3. Since more information from the simulation results in more conflict, it is logical that neural conflict definitely induces some sort of cyber sickness and also grows with the duration of immersion in the virtual environment. If the short duration like that, it will not be that much effect. But when the duration that is involved, immersion అంటే ఎక్కువసేపు మనం వర్చువల్ ఎన్విరాన్మెంట్ ఇమ్మర్స్ అయినప్పుడు, then in that case definitely this type of cyber sickness will be produced, that is neural conflict. I hope you understand. The next one is influence of simulation duration or exposure duration. Under this neural conflict itself, we can say that influence of simulation duration on cyber sickness. So one experiment was studied at University of Central Florida by Kennedy. Is it clear? They have done human factor studies at this particular university in the year 2000 to determine the influence of simulation duration on cyber sickness. The task that is considered is flying a helicopter, and subjects were what? Military pilots. The data was divided according to duration. Simulation session of 1 hour or less. 1 to 2 hours okay session, 2 to 3 hours like that, one more session. So simulation session over 3 hours. So this particular example showed that there is a linear relationship between the duration of simulation and the degree of simulation sickness. అంటే ఎంత ఎక్కువ డ్యూరేషన్ ఉంటే దానికి తగ్గట్టుగా సిమ్యులేషన్ సిక్నెస్ కూడా అక్కడ అవుతుంది అనేది ఒక పాయింట్. సో డ్యూరేషన్ ఆఫ్ ఇనిషియల్ ఎక్స్పోజర్ షుడ్ బి లిమిటెడ్ టు మినిమైజ్ discomfort. This is about what? Influence of duration. See here, that is what the statistics. Average total sickness score. As the score, as the duration is increased, 0 to 1 hours, sickness score is less. But when you consider 1 to 2 hours, sickness score is increasing. Similarly, 2 to 3 or even 3 or more, we observe that that total sickness score is increasing. Hence, we say that influence of simulation exposure duration is similar or linear relation, we can say. I hope you understand. That's about what? So neural conflict, and the other one is degree of interactivity. So in this class, we discussed about degree of interactivity and neural conflict. Is it clear? So in the next class, we discuss about the other part, that is adaptation. Okay. Before that, we just observe even repeated exposure is also one important factor on cyber sickness. User adaptation, that we'll discuss in the next class. I hope you understand. So that finishes a simple topic related to cyber sickness, one part, that is degree of interactivity and neural conflict. Here I'm going to stop the recording also. Thank you very much.